Hello everyone, myself Vinay Kumar. I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So now in this particular video, I will be teaching 8th chapter of mathematics subject in 8th standard, that is algebraic expressions and identities. So if you refer my previous videos, so there I have already discussed about certain algebraic expressions. So, any algebraic expressions contain numbers along with variables. So, for example, if I take an example of 5xy, so 5 is actually a number which is fixed, where x and y are known as variables. Why? Because here we don't know what is the value of x and y. Since we don't know what is the value of x and y, they keep on varying. Like for example, if you take same x in the other algebraic expression, then the value of x might be different. So if you take the same x in another particular algebraic expression, then the value of x might be different. That means x can take any value, y can take any value. So that means there is certain amount of variations in it. So that's why these particular alphabets which we use in algebraic expressions are known as variables, and whereas numbers is fixed. If you keep 5 in this particular expression, then the 5 will be same 5 in the other particular expressions as well. But x and y, it may vary depending upon the algebraic expressions. So that's why x and y or any other alphabets are known as variables, where 1, 2, 3, 4, 5, these are all numbers which will be there in that particular algebraic expression. So some natural numbers, even decimals might be there, fractions might be there. So all these particular numbers are fixed, and alphabets which we use in that particular expressions will be known as variables. So here you should remember what is a monomial, what is a binomial, what is a polynomial. So any algebraic expression which contains single term in it, so that is actually known as monomial. If a particular algebraic expression contains two units in it which cannot be added or subtracted, but they can just be expressed as it is. So such kind of algebraic expression which contains two units in it, so that particular algebraic expression will be known as binomial. Similarly, if 3 are there, then it is known as trinomial. Similarly, if 4 is there, then it is known as polynomial. Even binomial and trinomial are also known as polynomial. So if that particular algebraic expression contains two or more, then they are collectively known as polynomials. So here 5xy is just one unit. So that's why this is actually a monomial. So for example, if I give 5xy plus 6xz, so here you cannot add 5 and 6 because 5 has x and y as its components, where 6 has x and z as its components. That means, so this 5x have different variable and this particular 6xz have different variables. So when the variables are different, you cannot add the numbers. So this will be known as two-termed algebraic expression. So when this particular expression have two terms in it, then this is actually known as binomial. So this is actually binomial. So let's say if I give you 5x plus 6x, this cannot be a binomial because when you actually see here, the variable of 5 and 6 are same. So you can perform the addition operation between 5 and 6. So when you do the addition operation between 5 and 6, it will be 11x. X is common because here also x is there, here also x is there. So x is common. So now 5x plus 6x has reduced to 11x. That means it has got reduced to be a monomial. So here you cannot actually perform addition between 5 and 6 because the variables which this 5 and 6 is having are different. So that's why this particular algebraic expression is a binomial. So for example, if I give another example like 6xy plus 7yz plus 8ab. So if I give this particular algebraic expression, this is actually known as trinomial. This can also be known as polynomial because this has more than two terms in it. So here you can clearly see 6 as xy, 7 as yz, 8 as ab. That means no particular number has same variables. So all variables are different. Here xy is different than yz, yz is different than ab. That means all these terms are having different variables in it. So this actually shows this particular expression is a trinomial, or in general you can call it as a polynomial. So now coming to addition of polynomials or addition of monomials or binomials or addition in general, addition of algebraic expressions, always you should remember whenever you perform addition or subtraction between any kind of polynomials or algebraic expression, then the variables of those two particular terms should be same. For example, if I give you one particular algebraic expression as 5x and the other algebraic expression as maybe 7x, then you can perform addition between this 5 and 7 because this 5 and 7 have same variable x. So you can easily perform the addition between 5 and 7. So let's say if I give 5x and 7y, at that time you cannot add this 5 and 7. You cannot add or you cannot subtract as well because this particular 5 has x in it and this particular 7 has y in it. So variables are different. So when variables are different, you cannot perform addition or subtraction between the numbers. So this is actually one thing you should remember whenever you do addition and subtraction of a algebraic expressions. So even if I give you like 6xyz and 7xy, here you can see 7xy has xy in it. This 6xyz also have xy in it. But still you cannot perform addition between 6 and 7. You cannot perform subtraction as well. Because here you should take this xyz as one particular variable because you are actually multiplying x, y and z. So that's why that x, y and z, there is no x, y and z with 7. Only x and y is there with 7. So here also you cannot perform addition or subtraction between 6 and 7 since here the variable which this 6 contains is xyz and the variable which 7 is associated with is xy. So here you can clearly see the variables are not matching. Yes, of course, part of one particular variable might be matching with the other variable, but you should take the whole term. So this particular entire term you should consider and this particular entire term should consider. So they should contain the same variables. Then only you can perform addition. So here also you cannot perform addition or subtraction. So coming to multiplication and division in this particular algebraic expression. So if you want to perform multiplication and division of any two algebraic expressions or any three or more than that algebraic expressions, then you can directly multiply and divide the numbers which are there in that particular algebraic expression. If you understand the concept carefully, when you perform addition between two terms, so when you perform addition between two terms, you should be sure about the terms which are there. For example, if you have 7x and 5y, you cannot tell 7 plus 5 is 12. What is x plus y? So you don't know what is x because you don't know what is y. So you cannot take x and y common at all. So for example, if I take addition and subtraction and if I tell to add 5x and 5y, or if I tell to add 5x and 7y, you cannot add 5 and 7 because x and y are not common terms. But if I tell to add 5x plus 7x, then you can take, here also you are not adding 5 and 7 directly. You are actually taking x common, here also you are taking x as common, and you are actually clubbing the numbers together by taking this algebraic expression as common. Then only you are performing this addition and you are telling 7 plus 5 is 12 and x is there, so x. So like this you are actually performing the addition of two algebraic expressions. So whereas in multiplication 5x and 7y is there, then you can easily perform multiplication because here there is no need of taking common. But in addition and subtraction you should actually take common of this particular algebraic expression. You should add and subtract only if that particular two numbers have same variables associated with it. Here, because in multiplication there is no requirement of taking common. Directly you can multiply x and y, it will become xy. You can multiply 5 and 7, it will become 7 5s are 35. So this is what you should remember while adding and multiplying two algebraic expressions. So here directly you can do, while adding you should see through that whether that particular two numbers have the same variables. If those two numbers have same variables, then take that same variable common and add those two numbers, and then take that common variable and put to the answer. Just like I did 5x plus 7x as 12x. Here 5x into 7y is 35xy. But like this you cannot add 5x and 7y. That is, you cannot perform 5x plus 7y. You should just keep it as it is, because you don't know what is x and you don't know what is y. So when you don't know what is x and what is y, then how can you perform addition? Because according to BODMAS rule, you should always perform multiplication first, and then only you can proceed with addition and subtraction. So now if I tell you to add 5x and 7y, according to BODMAS rule, first you should perform multiplication. That means first you should perform the multiplication operation which is there between this 5 and x, and you should perform this multiplication operation which is there between 7 and y. Only after that you can actually add 5x and 7y. But here you don't know what is the value of x. Here you don't know what is the value of y. So how you can actually multiply y with 7? How you can actually multiply x with 5? You cannot do that because you don't know the value of x. You don't know the value of y. So that's why according to BODMAS rule, first you should solve this multiplication and then only you can perform addition of these two. But here since you don't know x and y, so you are not multiplying x and y with the corresponding numbers. So when you are not only performing multiplication operation, you cannot perform addition operation as well, because you should first perform multiplication and then you should perform addition according to BODMAS rule. Here you are not able to do multiplication at all in the first place. So that's why you cannot do addition of algebraic expression which has two different variables. So this pi x as its variable and 7y as y as its variable. So both are different variables. Here you are not performing multiplication between those two, 7 and y and 5 and x. So when you are not performing multiplication with those two, you cannot add. But if I give 5x and 7x, here also you cannot perform multiplication between x and 7. Here also you cannot perform multiplication between x and 5. But here x is there. That means this 5 and 7 contains same variable. So here you can easily take x common and you can actually add 5 plus 7 and the answer will be 12x. But if I give different algebraic expressions like 5x plus 7y, here you cannot perform multiplication between y and 7. Here you cannot perform multiplication between 5 and x. So since you don't know what is the value of this and you don't know what is the value of this, you cannot perform addition or you cannot perform subtraction. So you should just leave this as 5x plus 7y, which will be a binomial, or you can generally call it as a polynomial. You can easily perform multiplication if two numbers have different variables. For example, like 5x and 7y is there, you can easily perform multiplication between these two and you can easily keep answer as 35xy. Because here x is also involved, y is also involved after multiplication. But in addition, you don't know where x will be there and where y will be there, because x is associated with 5 and y is associated with 7. So how can you perform addition? You cannot do, because you don't know what is x and y. But here even though you don't know x and y, but this x and y will also be there in your final expression as well. So that's why you can easily perform multiplication between x and y, and you can easily perform multiplication between 5 and 7. It will become 35xy. Similarly, if I give another algebraic expression where it will like 4x divided by 2y. If 4x divided by 2y is there, you can easily divide x and y, and this will be actually 4 divided by 2. 4 divided by 2 will be 2x by y. So the answer for 4x divided by 2y will be 2x plus 2x divided by y, because 4x divided by 2y is actually 4x by 2y. So 2 ones are 2 2s are. So x and y will be remaining as it is. So it will be 2x by y. So you can directly perform division and multiplication, but while doing addition and subtraction, you should always see through that the algebraic expression contains, like two algebraic expressions should contain same variables. Then only you can perform addition, because you can take that variables common and you can perform the addition for that numbers. Based on this learning, we will actually solve exercise 8.1. So coming to the exercise 8.1, which is there in this particular chapter. In first question, they have actually given 4 different questions and they have actually asked to add the terms which are given in that particular questions. So coming to the first question, in this particular first question, they have given AB minus BC, comma BC minus CA, comma CA minus AB. So they have given three terms and you should actually add these three terms. So let's see what we will get if we add all these three terms. So AB minus BC plus, you should open bracket and then take second term, because here minus is there, you should not get confused with that. So that's why it is better to open the bracket and write the second term inside bracket. Similarly, open another bracket, do the addition and open another bracket and write the third term, that is CA minus AB. So you have got AB minus BC plus BC minus CA plus CA minus AB. Now remove this bracket, AB minus BC. So this plus into plus will be plus, plus into minus will be minus CA, plus into plus will be plus CA, plus into minus will be minus AB. So finally you have got AB minus BC plus BC minus CA plus CA minus AB. Here you can clearly see BC and BC have common algebraic expression, because this particular expression also have BC and this particular expression also have BC. This is nothing but 1 BC, 1 BC. So here you can see 1 minus 1 BC plus 1 BC. So you can easily cancel these two. Similarly, you can cancel AB and minus AB. Similarly, you can cancel minus CA and plus CA. So total answer for this first question will be 0. So coming to the second question, in this particular first question, you have A minus B as one term, A minus B plus AB as one term, B minus C plus BC as second term, C minus A plus AC as third term. So we'll add all these three particular terms. So A minus B plus AB plus, write this second term inside bracket, B minus C plus BC plus, write this third term inside bracket, that is C minus A plus AC. Now remove the bracket. So A minus B plus AB will be there. So plus into plus will be plus, so plus B will be there. Plus into minus, it will be minus, so minus C will be there. Plus into plus, it is plus, so plus BC. Plus CA minus A plus AC. So now you can see any algebraic variables are actually in this particular algebraic expression. You can see any two terms have same variables or not. So here you can see minus B and plus B is there, which has same variable BB. So B and minus B gets cancelled each other. And here you can see C and C can get cancelled each other. Minus A and plus A also can get cancelled each other. So here AB is remaining, BC is remaining, AC is remaining. Now you cannot perform addition between these two, because AB is not same as BC, BC is not same as AC. So the total answer for this second question will be AB plus BC plus AC. Similarly, using this logic, you can solve the third and fourth question as well. Coming to the second question in this particular exercise, there they have asked to subtract one particular algebraic expression from another algebraic expression. So coming to the first question or the A question in this particular second question, there they have actually asked to subtract 4A minus 7AB plus 3B plus 12 from 12A minus 9AB plus 5B minus 3. So here always the number which is there after from should be written first, and you should do minus, open the bracket and write the first term. That means from, that is the second term. You are actually subtracting the first term from second term. So you should actually write second term first. That is 12A minus 9AB plus 5B minus 3. So now you are performing subtraction between these two. So from this you are actually subtracting this. So that means minus, open the bracket and write the first term, that is 4A minus 7AB plus 3B plus 12. Close the bracket. So now you can remove the bracket. 12A minus 9AB plus 5B minus 3. So minus into plus 4A will be minus 4A, because minus into plus is minus. So here you should see minus into minus 7AB is there. So minus into minus will become plus 7AB. Minus into plus will be minus 3B, minus into plus will be minus 12. So now you can compare which particular two expressions have same variables. Here you can see 12a and 4a has same expression, that is a and a. Here 9ab and 7ab has same expression, that is ab and ab. Here 5b and 3b has same variable, sorry. So b and b, so same variables are there. So this 12a and 4a has same variables, 9ab and 7ab has same variables, 5b and minus 3b have same variable. So you can perform addition and subtraction between 12a and minus 4a. So 12 minus 4 will be 8. So 8a will be common. Similarly, minus 9ab plus 7ab will be minus 2ab, because minus 9 plus 7 is minus 2. So plus 5b minus 3b will be plus 2b. Here you can perform minus 3 minus 12. So minus 3 and minus 12 will be minus 15. Now you cannot add or subtract these terms, because here 8a has a as its variable, 2ab has ab as its variable, 2b has b as its variable, 15 has no variable. So that means you cannot perform addition or subtraction between these terms. So 8a minus 2ab plus 2b minus 15 is the answer for A question in this particular second question. Coming to the B question in this particular second question, there also they have asked 3xy plus 5yz minus 7zx from, so you should actually subtract this particular term from, they have given second term as well, that is 5xy minus 2yz minus 2zx plus 10xyz. So you should actually take this particular term in the first place and then minus and take the first term inside bracket. So let us take the second term, that is 5xy minus 2yz minus 2zx plus 10xyz. So minus, open the bracket and write the first term. What is first term? That is 3xy plus 5yz. This is actually z, so 5yz minus 7zx. Close the bracket. Now you can actually open this bracket and bring the terms outside bracket. So 5xy minus 2yz minus 2zx plus 10xyz, whichever the second term is. So now minus into plus 3xy will be minus 3xy, minus into plus 5yz will be minus 5yz. So minus into minus plus, here you can see minus is there, here minus 7zx is there. So minus into minus, it will become plus 7zx. So now you can compare which particular two terms have same variables. Here you can see 5xy and 3xy has same variables. You can perform addition between those two. So here plus 5 is there, here minus 3 is there. Plus 5 minus 3 is plus 2. So plus 2xy. Here minus 2yz is there, here minus 5yz is there. So you can perform addition between these two. Minus 2 minus 5 will be minus 7yz. So here minus 2zx is there, here plus 7zx is there. So here also zx is there, here also zx is there. You can perform addition between minus 2 and plus 7. Minus 2 plus 7 is plus 5zx. So here 10xyz is there. So that also you should actually add here. So that is 10xyz. So the answer for this B question will be 2xy minus 7yz plus 5zx plus 10xyz. So coming to the C question in this particular second question, this is also similar to the A and B question. So whatever the term which is there after from, you should take that in the first place, put minus, open the bracket and take the first term there, like before from, whatever the number is there, algebraic expression is there, you take there. So similarly, how I solved A and B, you can solve that and you can get the answer for C question as well. I have explained you how to do the multiplication and division of two monomials or two algebraic expressions. So now let us go on solving exercise 8.2, which is based on the multiplication of algebraic expression. Coming to the exercise 8.2, in that, in first question, you have 5 different questions. So in each question, they have given two monomials. You should actually perform multiplication between those two monomials. So coming to the first question, in this particular first question, there they have given 4 and 7p. As I told you before, you can directly perform multiplication between two terms which has different variables. So here 4 has no variable, 7 has p as its variable. So 4 into 7p will be 4 sevens are 28p. So coming to the second question in this particular first question, there they have given minus 4p and 7p. So when you perform multiplication between minus 4p and 7p, it will be 4 into 7. So minus 4 into plus 7 will be minus 28. Similarly, you should perform multiplication between p and p as well. So what is p into p? P into p is the 2 times multiplication of p. So that will be p power 2 or p square. So the answer for second question is minus 28 p square. So coming to the third question in this particular first question, there they have given minus 4p and 7pq. So now when you perform multiplication between minus 4p and 7pq, you will get minus 4 into 7, that is minus 28. P into pq will be p into p into q. So that means p into p into q. So what is p into p? P into p will become p square into q. So what is p square into q? P square into q will be p square q. So p into pq will be p square q. So the answer for third question in this particular first question will be minus 28 p square q. Coming to the fourth question in this particular first question, there they have given 4p cube and minus 3p. So when you perform 4p cube into minus 3p, it will be 4 into minus 3. 4 into minus 3 is minus 12, because 4 3s are 12, plus into minus will be minus. So minus 12, p cube into p will be p power 4. So one thing I should actually explain here, whenever you are multiplying variables or whenever you are multiplying certain numbers which has power in it, then you should always remember, for example, if I have p cube into p, this actually represents p power 3 plus 1, because just p is there means in the power 1 will be there by default. So here when you actually multiply these two p's, you should actually add the powers. So this I will be explaining in exponents and powers chapter, which is the next or the 10th chapter of this particular 8th standard mathematics. Here just I will give a hint about it. So here p is actually known as base and the power is actually known as 3, that is actually known as power. So here if base of two particular expressions are same, then you can perform the addition of powers. For example, if I have a power 3 and a power 5, here you can see the base is same, that is a. Here also a is there, here also a is there. Then you can perform addition between 3 and 5 if you are actually multiplying this a power 3 and a power 5. So when you are multiplying a power 3 and a power 5, since base is same, you can just write it straight away as a, and you can add the power this like this, 3 plus 5. So a power 3 plus 5 will be a power 8. So generally if you want to write a formula for this, so it will be a power m into a power n. Here base is same, so you can actually add the power. So that is a power m plus n. Similarly, if you have a power m divided by a power n, then also you can write the a as it is, but here you should actually perform subtraction between these two powers, that is actually m minus n. So whenever into multiplication is there, you can perform addition between the powers. Whenever division is there, you can perform subtraction between the powers, only if base of those two terms are same. Here a is there, here also a is there, base is same, so hence I am performing the operation between powers. So coming back to this fourth question, here also p cube and p is there. So here you can clearly see p cube into p has same base p. So here also p is there, here also p is there. Here it is p power 1. So according to this particular formula which I showed, a power m into a power n, when bases are same, you can write that base as common and you can actually add m plus n. So here it will be a power m plus n. Here also p is there, so same base is there. So I will just write p and add this 3 and 1. So it will be 3 plus 1. So 3 plus 1 is p power 4. So that means 4. So p power 4 is there. So here we were actually multiplying 4p cube into minus 3p. So here 4 into 3 will be minus 12 and p cube into p will be p power 3 plus 1, that is p power 4. So minus 12 power p minus 12 into p power 4 is the answer for this fourth question. So coming to the fifth question in this particular first question, there they have given 4p comma 0. So whenever you multiply anything with 0, it will always be 0. That means you're actually multiplying with something which is not there at all. So whenever you're actually performing multiplication with which is not there at all, then you will not get result, because multiplication is actually the application of addition. Because when you perform addition of certain numbers for a certain time, you are actually converting that into multiplication. For example, if I say 2 into 4 is 8, here 2 into 4 represents 2 is added 4 times and then you are getting 8. So here you are adding 2 8 times, 2 4 times, and you are actually getting 8 as your answer. So similarly, when you are actually adding 2 0 times, that means literally you are not adding 2 at all. So when you perform 2 into 0, what will be the answer? So when you perform 2 into 4, it will be 4 2s are 8. So here the meaning of 2 into 4 means 2 plus 2 plus 2 plus 2. That means 2 you are actually adding 4 times. So here you are actually adding 2 4 times. So that's why you are actually taking 2 into 4. So instead of adding this, you are simply multiplying 2 with 4 and getting the answer. So that's why multiplication is one kind of application of addition. So here what will be 2 into 0? So the significance of 2 into 4 is that you are adding 2 4 times. So the significance of 2 into 0 is that you are adding 2 0 times. That means literally you are adding nothing. So literally when you are adding nothing, you will get nothing only. That means you will get 0 only. So that's why 2 into 0 will be 0. So like this, if you take any numbers or any algebraic expressions or any rational numbers, irrational numbers, decimals, whatever, like whatever fractions, whatever numbers you take, and you are multiplying that with 0, means you are actually adding that particular term 0 times. So that means you are not adding anything. So it will become 0. So that's why anything multiplied with 0 will always be 0. So 2 into 0 is 0, 3 into 0 is 0, 4 into 0 is 0. Anything into 0 is also 0 only. So here also in this particular fifth question, in this particular first question, there they have given to perform multiplication between 4p and 0. So 4p into 0 is 0, because anything into 0 will be 0. So 4p into 0 is also a 0. So coming to the second question in this particular exercise 8.2, there they have given length and breadth of rectangles, and they are actually asking to calculate area of that particular rectangle. So what is the formula to find area of a rectangle? So formula to find area of a rectangle is length into breadth. So coming to the first question, there they have given p comma q. So p is length and q is actually breadth of that particular rectangle. So what will be the area? Area will be p into q. What is p into q? P into q is pq. So similarly they have given like 5 different lengths and breadths. So you can actually perform the multiplication between those two algebraic terms. So similarly whatever you have done in the first question, the same thing you are doing in the second question, but here you are actually calculating the area of rectangle. Area of rectangle is again length into breadth. So there also they have given length as one algebraic expression and breadth as another algebraic expression. You are multiplying 2 to get the area of rectangle. So the second problem which they have given is 10m and 5n in this particular second question. So 10m is length and 5n is breadth. So what will be the area? It will be 10m into 5n. So what is 10 into 5? 10 into 5 is 50 mn. So like this you can go on performing length into breadth, and you can go on calculating areas of rectangles in this particular second question. So coming to the third question, here also they have actually given table. They have actually told to fill this particular table. So they have given certain rows and certain columns here. So these are the certain columns and these are the certain rows which they have actually given in this particular table. So here they have given different algebraic expression here, 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 and here also they have given different algebraic expression. So you should actually multiply this particular algebraic expression with this particular algebraic expression to get answer over here. So you should multiply this particular algebraic expression with this to get answer here. So you should multiply this algebraic expression with this to get answer here. You should multiply this algebraic expression with this, so to get answer over here. So like this you should perform multiplication with all these algebraic expressions, and you should go on filling this particular table which is there in this particular third question. I will just show one example. So here in the first place they have given 2x, in the second they have given minus 5y, third they have given 3x square. Like this they have go on giving the different algebraic terms in row wise, and in columns they have actually given 2x minus 5y. The same numbers they have actually repeated here as well. So like this it goes on. So now to put number in this particular first box, you should actually multiply this 2x into 2x. What is 2x into 2x? 2 2s are 4, x into x will be x square. So to fill this second box in this particular row, you should actually multiply 2x with minus 5y. So 2 minus 5 is minus 10, x into y will be xy. So here 2x is there, here 3x square is there. 2 into 3 will be 3 2s are 6, x into x square will be x cube, because x into x square will be x in x power 1 plus 2, that will be x cube. So 1 plus 2 is 3, so x cube. So here you got 6x cube. Like this you can actually multiply minus 5 into 2x and you can put answer over here. Minus 5 into minus 5 you can put answer here. Minus 5y into 3x square you can put answer here. Like this you can go on filling this particular table. Here also in third question, basically you are doing multiplication between two monomials. Similarly, how you have done in first question and second question, the same logic you are applying in this third question, and you are actually filling the tables in this particular third question. Coming to the fourth question, here they have actually asked to find the volume of a rectangular box or a cuboid. So here, coming to the first question in this particular fourth question, there they have given 5a, 3a square and 7a power 4. This is actually length, breadth and height of a particular cuboid. Now you should actually find the volume of this particular cuboid. So what will be the formula to find volume of a cuboid? It will be length into breadth into height. So V is equal to, what is length? 5a, what is breadth? 3a square, what is height? 7a power 4. So here you can perform addition between, multiplication between 5, 3 and 7 directly. So what is 5 3s are 15. 15 into 7, 15 into 7 will be 90 plus 15, that is 105. So here you can see a into a square into a power 4 is there. So when you perform a into a square into a power 4, here you can clearly see base is actually same. Here also a is there, here also a is there, here also a is there. So when base is common, you can just write a and go on adding the powers. Here a means it is a power 1. So it will be 1 plus 2 plus 4. So what is 1 plus 2 plus 4? It will be plus 7. So a power 7. So when you perform multiplication of a into a square into a power 4, it will become a power 7. So 5 into 3, 15, 15 into 7 is 105. A into a square into a power 4 is a power 7. So the volume of this particular cuboid or rectangular box is 105 a power 7. That is the answer for first question in this particular fourth question. So coming to the second question in this particular fourth question, there they have given 2p, 4q and 8r as length, breadth and height. So here also you should find volume. So it will be 2p into 4q into 8r, because length into breadth into height is the volume of a cuboid. So when you perform 2 into 4 into 8, it will be 4 2s are 8, 8 8s are 64. P into Q is PQ, PQ into R is PQR. So the answer for this second question in this particular fourth question is 64 PQR. Similarly, third question and fourth question which is there in this particular fourth question, you can solve like this. There also they have given length, breadth and height. You should actually multiply all those three terms and you should get the volume. Basically, the main purpose of doing all this particular exercise question is to make you understand how to actually multiply algebraic expressions, how to actually multiply especially monomials. So in next exercises you will be learning how to multiply monomial with a polynomial, and you will also learn how to multiply polynomial with a polynomial. So like this you will be learning in exercise 8.3 and 8.4. In this particular exercise 8.2, you are basically trying to learn monomial into monomial, that is multiplication between two monomials. So coming to the fifth question in this particular exercise 8.2, there they have also given three terms and you should actually perform multiplication of those three terms. So here, coming to the first question in this particular fifth question, there they have given xy, yz and zx. You should actually perform multiplication between these three. So let us perform multiplication between these three terms. So xy into yz into zx. So here you can clearly see, you can actually perform multiplication between this y and y. So y into y means it is actually y power 1 into y power 1. So what is y power 1 into y power 1? Because y is common base. So here also y is there, y is there. So you can add these two powers. So that is 1 plus 1. So y power 1 into y power 1 will be y square. That is y power 2. So here if you perform xy into yz, it will be equal to x y square z. So x is there, y into y is y square z. So into zx. Now you can perform multiplication between these two, because totally you should perform multiplication between all these three. So first two terms I have multiplied, I got one term. So that term I will be multiplying with third term. So I'll get the total result of doing multiplication of those three terms. So x y square z into zx. So here you can see x is there, here also x is there. So x into x will be x square, that is x power 1 into x power 1 will be x power 1 plus 1. So that is x power 2. So that is x square. So here x into x is x square, y square will be there as it is. So here z into z will be z square. So the answer for this first question in this particular fifth question is x square, y square, z square. So coming to the second question in this particular fifth question, there they have given a minus a square and they have given a cube. So when you perform multiplication between a minus a square, here they have given minus a square into a cube. So here you can see this particular number, this particular number, this particular number has 1, 1, 1. So a means it is actually 1a. Minus a square means it is actually minus 1 a square. A cube is actually 1 a cube. You can take a common here, like you can perform multiplication between 1 into minus 1 into 1. So what is 1 into minus 1 into 1? It will be minus 1 a into a square into a cube. Now you should do a into a square into a cube. So all these three has same base, that is a. You can easily add powers. So here a power 1, a power 2, a power 3 is there. So a power 1 plus 2 plus 3, that is actually 6. So here it will be minus 1 into a power 6, or it is minus a power 6 in general. So the answer for the second question in this particular fifth question is minus a power 6. So coming to the fifth question in this particular fifth question, there they have actually given m minus mn plus mnp. So when you perform multiplication between these three algebraic terms, it will be m into minus mn into mnp. So minus mn means it is actually minus 1 into mn. So here 1 into m. So 1 into minus 1 will be minus. So it will be, when you perform multiplication between these two terms, it will be minus m into m is m square and n will be there as it is. So here m into m is m square and n is there. So minus into plus is minus. So minus m square n into mnp. Again here minus into plus will be minus. M square into m will be m square into m will be m power 2 plus 1, because here this m has 1 and this m has 2. So base is same. Here also base is same. So you can perform addition between 2 and 1. That will be 2 plus 1. So m power 2 plus 1 is m cube. So m square into m is m cube. So minus m cube, minus into plus minus m cube. N into n will be n square, because n power 1 into n power 1 is n power 1 plus 1, that is n power 2. So n square into p will be there as it is. So the answer for this fifth question in this particular fifth question is minus m cube n square p. So till now I have solved all 5 questions in this particular exercise 8.2 and I have also solved exercise 8.1. Like this, I will be uploading part 2 video as well, where I will be discussing monomial into polynomial, polynomial into polynomial, and also exercise 8.3 and 8.4, which is there in this particular chapter. So like this, if you want to learn more physics, chemistry and mathematics in my YouTube channel, then please do subscribe to my YouTube channel and stay tuned with my YouTube channel. Thank you.